Okay, so last video, I talked about how some students will assume if you have x equals a negative number, that can't work. That's not true. You can't take a logarithm of a negative number, but you can have a negative solution. So I want to do an example, and you can write this off to the top of your paper here. If I have this example here, I have the log of base 2 of x plus 20 equals 3. Write that a little better, kind of messy here. X plus 20 equals 3. If I solve this, I would get 2 to the third power equals x plus 20. I get 8 equals x plus 20. I subtract 20 from both sides. I get negative 12 equals x, or x equals negative 12. And some people say, oh, that doesn't work because, yeah, we can't have a negative x value. You can have a negative x value. You just can't have a negative logarithm. So I check this. My phone's ringing. Let me grab that real quick. Okay, so when we put a negative 12 into here, we get log base 2 of negative 12 plus 20. Does that equal 3? We get log base 2, and negative 12 plus 20 is 8. And that's true, because 2 to the third power is 8. So we had a negative answer, and it worked because I'm taking a logarithm of a positive number. So we took log a positive number. That's okay. Even though our answer is negative, I took a logarithm of a positive number. This ended up making it positive. So you can have a negative answer, you just can't take a negative logarithm. You can have negative solution, just can't take logarithm of a negative number. Excuse me. Okay, so let's go to example 8. And here's the same idea. I have multiple logarithms in the natural log, and I want to kind of condense this. So on the left-hand side, notice how this is a difference of two logarithms, in this case natural logarithms. I can use the quotient rule. So I have the natural log of x plus 2 over 4x plus 3, and that's going to equal the natural logarithm of 1 over x. Notice that the natural log of something equals natural log of something. These two things have to be equal to each other in order for the statement to be true. This means that x plus 2 over 4x plus 3 has to equal 1 over x. There's two ways to solve this. I can go ahead and just cross multiply, or I can just multiply both sides by x times x plus 3, which is the lowest common denominator. So I can multiply x times 4x plus 3, and x times 4x plus 3. Because that would cancel out this side, this. That would cancel out this. So end up with x times x plus 2 equals 1 times 4x plus 3. So x squared plus 2x equals 4x plus 3. So x squared, and then we'll subtract 4x on both sides, minus 2x, and then we'll subtract 3 on both sides, minus 3 equals 0. So I'm going to bring up here, so I get x minus 3x plus 1 equals 0. So x equals 3 or negative 1. And I'm going to check the 3. Natural log of 3 plus 2 minus the natural log of 4 times 3 plus 3. Does that equal the natural log of 1 over 3? The natural log of 5 minus the natural log of 15, does that equal natural log of 1/3? And there's a couple ways to do this. Since you have natural log, you can actually type natural log 5 minus natural log 15 and get a number in your calculator. And I get negative 1.099 approximately. And then the natural log of 1 divided by 3 is negative 1.099. So it looks like both sides are equal to one another. Another way to do this would be to use the quotient rule and say with the natural log of 5 over 15, did that equal the natural log of 1/3? Well, that's the same thing as 1/3 on the side, and that would be true also. But 3 does work. Now I gotta check the negative 1. So check x equals negative 1. The natural log of negative 1 plus 2 minus the natural log of 4 times negative 1 plus 3. Does that equal the natural log of 1 over negative 1? Well, this right here would be the natural log of 1 minus the natural log of negative 1. Does that equal the natural log of negative 1? And you can't take logarithm of a negative number. So the negative 1 would not be a solution. So the only solution I have would be call that one out and circle this one. Okay, so the next problem is to go ahead and do it on your own problem, and then pause the video and then check your answer when you replay the video. Okay, so on your own problem, I solved this equation. I wanted to use the quotient rule and condense this into right-hand side one logarithm. And I multiplied both sides by x plus 1 to get rid of this x plus 1. That would cancel this out. So I end up getting secondary equation, and I get x equals 4 or 5. And when I checked 4 into there, I end up getting the statement of the natural log of 1 equals the natural log of 5 minus the natural log of 5. Well, this right here equals 0. So the natural log of 1 equals 0. Well, the base is e. So e to 0 equals 1. That's true. That one works. So x equals 4 works. When I checked x equals 5, I put it in there, and I ended up getting this statement right here. And I typed it in my calculator, and I ended up getting 0.693 on both sides, approximately. Or if I wanted to do it by hand without a calculator, I would get the natural log of 2 equals natural log of 2. So both of them work. I circled both of them because both of them worked. Okay, so this is one case where both worked. The previous examples we had, one of them worked, and then you might have some on the exam where none of them work. So you want to check. Make sure you show this check. Make sure you're checking this and showing the check. If I don't see the check on the exam, I'm going to assume you didn't do it, and you won't get credit for doing it. Okay? Now, example 9 is a word problem, and medical research indicates that the risk of having a car accident increases exponentially as the concentration of blood alcohol in the blood increases. So the more alcohol you have in your blood, the more likely you have an accident. That should make sense. This is modeled by this function here, and the X is the blood alcohol content, and R is the risk of having a car accident. What blood alcohol concentration corresponds to a 17% risk of car accident? How is shown in the graph. So they're telling you they want to know what is the blood alcohol concentration corresponding to 17% risk. So R is the risk. We put 17 in right there for R. Okay. So again, the risk equals 6 times e to the 12.77x. And we're going to do 17 for the risk equals 6e to 12.77x. Remember, x stands for the blood alcohol concentration. We're trying to figure that out. What blood alcohol concentration? We're looking for that. So again, we're going to solve for x here. So I want to get this exponential expression alone. Then we get rid of this 6 here. I'm going to divide both sides by 6. So I get 17 over 6 equals e to the 12.77x. Now I'm going to use the, I'm going to take the natural log of both sides. Go back to how to solve an exponential equation. Like the natural log of 17 over 6, and this right here, these negate each other out because base E. The E is down here. Oops, just lost it there. The E is down here, and it has the base E here, so we end up with just 12.77x. Okay. I'm going to divide both sides by 12.77. X is going to equal approximately, so in my calculator I'm going to take the natural log of 17, divide by 6, and figure that out. It equals, and divide by 12.77. I get approximately 0.082. If you have a blood alcohol concentration of 0.082, you're going to have a 17% risk of a car accident. Okay, so here's my sentence. Okay, a blood alcohol concentration, that's the abbreviation, of 17%, a blood alcohol concentration of, my bad, it should be 0.082 would carry a risk of 17% for a car accident. That's a pretty high risk. You don't want to have any risk at all. A 17% risk, that's pretty bad. So if you have the concentration of that, and you can see why the law requires a certain level of blood alcohol concentration before you're in trouble. In this case, 70% is a pretty big risk. They would not want that level of concentration in your blood. Okay, so let's go ahead on your own, do the same formula in this example to say what would happen if you have a 7% risk of a car accident. Okay, so go back to this formula right here. Okay, go ahead and pause the video and then do this one on your own. Okay, for example, I ended up getting x equals 0.012. So a blood alcohol concentration of 0.012 corresponds to a 7% risk of a car accident. And just in many states, it says that drivers under 21, if they have a blood alcohol concentration of 0.01, they would lose their driver's license. So, and you can see why 7% risk of a car accident is pretty high. I wouldn't want to be in a situation where someone has that alcohol concentration level and that risk right there of 7%. Okay. Okay, the next example, I have 4 more problems to go through, and I think I'm getting ready to run out of time. Look at my time there. I have 2 more minutes left on this video. So, we'll start with this next example in the next video, so I'll go ahead and stop it right here. And then the last part, we'll go over the next few examples or word problems.